Good afternoon, everyone. Welcome to our last episode of Webinar Series 2022 by School of Architecture and Design Architecture Program. My name is Yanit Malichai, or Atom for short, and it is my pleasure to serve as the webinar's moderator on behalf of School of Architecture and Design Architecture Program, KMUTT University of Technology, Thonburi. This webinar is the last episode focusing on embracing digitalization, how architecture education can leverage new technologies for our future. Architecture Program Webinar Series 2022 has been initiated to outreach and educate the public together with international professionals regarding School of Architecture and Design direction through the presentation of research and work by Architecture Program of School of Architecture and Design, KMUTT, and our alliance. Today I'm here with Dr. Acharawan Chutarat, Assistant Professor Waraluk Pansuwan, Ms. Sukhumarn Thamwiset, and our international experts Professor Hiyama Kyosuke, lecturer in Architecture Program at Meiji University from Japan. Our theme today is Embracing Digitalizations, how architecture education can leverage new technologies for our future. And before we starting today's lecture, let me introduce you to our first guest speaker. Professor Hiyama Kyosuke is a lecturer in Architecture Program at Meiji University with a PhD in engineering. He graduated from Waseda University and graduate school in University of Tokyo. In 2022, he was awarded with AIJ, or Architectural Institute of Japan Prize, and SHASE, or the for Society of Heating, Air Conditioning, and Sanitary Engineers of Japan Prize in 2022, 2014, and 2016. Please welcome Professor Hiyama Kyosuke on stage for the discussions of environmental simulations in architectural educations and design process. Welcome.
Thank you very much for the nice kind introductions. So, can I start my presentation from now?
Yes, you may start your presentation.
Okay, so wait a minute. I'd like to back to my first page. Okay, so anyway, thank you very much for the preparing for many things for this webinar. I'm very happy to be invited for the lecture here. And today I'd like to introduce my works and what I do in my schools for education. So my name is Kyosuke Hiyama, as it is introduced, and I'm from Meiji University, Japan. And I'm working for education and research of architectural environmental engineering. Environmental simulation tools, such as building energy simulations, are my main tool for my research and educations. Then today, I'd like to talk about what I do with my students and how I teach them those technologies and how they become matured using them and to develop new technologies. Okay. This is my short biography. It has already been introduced some by Atom, so I'd like to skip it now. So there are the contents for my talk today. First, I would like to introduce my student work. They challenge a design competition to learn how to use environmental simulation tools for architecture design. And next, I will explain how it's education of my lab, Architecture Environmental Design Laboratory. To the challenge, wait a minute. To challenge the design competition, I assign a task to students to learn how to use simulation tools by themselves. Yeah, okay. It will be a useful exercise in discarding and selecting information and arriving at appropriate knowledge in this era of information overload. Through the discussion on their challenge, I guide them to develop problem-solving skills as well as problem-fighting skills. Then I will introduce my graduate student work to show how the students could take on new challenge on their developed skills, as well as how it leads to new technologies. So these slides briefly explain what is our team. I'm leading Architecture Environmental Design Laboratory. There are 3 staffs, 2 PhD students, 7 graduate students, and 10 undergraduates. So first, I will talk about the challenge of undergraduates. They apply for student architecture design competitions. Uh, they apply for this competition, so-called SABET Design Award. It is organized by Support Association for Building Environment Design. The scope of the competition is providing an educational curriculum that crosses the boundaries between universities and companies. It awards outstanding design works that utilize environmental simulations. This is one of my students' work, Museum of Repetition and Light. It won the grand prize in 2020. They redesigned their past work using environmental simulation tools. It is an art museum that allows for diverse special experiences. The change in natural lighting breaks the simply repeated room plans. The most highly rated point in this competition is the daylighting design and its simulations. They did daylighting and glare analysis and created 4 variable spaces with unique daylight measures: skylight, high window, water surface, reflectance, and light tube. Each design was carefully designed by using daylighting simulation tools. They also use the CFD analysis, computational fluid dynamics analysis, to design wind environment. Wind paths, natural ventilation are designed to improve the comfort. Climate analysis is easy to be done by using environmental analysis plugins for rhinoceros. Thermal comfort and energy usage are analyzed by simulating tools based on Energy Plus. Here's the other work from my student group. From 2020, they continuously won some prizes. I'm proud of their accomplishment and ability to compete. From here, so I'd like to move to talk about how they achieve their ability to compete in these competitions. Here are my education policies. So first, I believe that it is the most important thing is to provide opportunities and work environments. And this is the only thing that faculty can ensure for students. I provide variable simulation software as well as high-performance computer that improve their work efficiency. As a modeling tool, they mainly use rhinoceros. Environmental analysis plugins, they use ladybug honeybee for grasshopper. It's very useful. It can stimulate students' interest to integrate environmental analysis in their design processes. For the environmental simulation, daylight and energies, we owe a lot to climate study. To predict more details in terms of building energy use, we use Design Builder that uses Energy Plus for the simulation solver. For computational fluid dynamics (CFD) analysis, we have some software and use them according to the objectives. However, I prepare the environments for them, but I don't teach so much for how to use them. First, I think I don't have to teach it. Instruction on how to operate the software are easily available. Most information can be found on YouTube. And I believe that they should develop skills to reach right information by themselves. The process becomes a useful exercise in discarding and selecting information and arriving at the appropriate knowledge. The skill is very important to survive in this era of information overload. And software development proceeds at a very fast speed. So if they could reach the up-to-date information, I believe it gives them some advantage for the competitions. And I don't guide what to do and when to do it architectural design process. First, challenges vary with each architectural design processes. So they have to find what they would like to do, as well as what they should do and how to proceed it by themselves. These processes can help them to develop problem-solving skills as well as problem-finding skills. I believe that innovative design and technology are emerged from the discovery of new problems and challenges. In these contexts, I put an importance to develop problem-finding skills and problem-solving skills in my education. In these processes, I encourage them work together. Architecture design is a team process. Then the process becomes a useful exercise to develop a skill to work in collaborations. In UNESCO UIA Charter for Architecture Education, the collaboration work is also recommended to integrate it in the education curriculums. Now my school is enrolled in a program called JABI, Japan Accreditation Board for Engineering Education. That follows this charter, so we encourage them to work together in these programs. Then, so what I should do for them? We discuss simulation outputs in depth. Perform simulation itself is not so difficult task, it's very easy task. If you have software and PC, you can do it. However, understanding simulation outputs correctly, it needs a training. I would like to develop human resources to analyze the simulation outputs and provide useful feedback to update architectural design. The process to use simulations to improve building performance is called as Design Performance Modeling (DPM). According to Architectural Guide to Integrating Energy Modeling from AIA, the American Institute of Architects, DPM informs design decisions by predicting a building's performance with respect to energy efficiency, daylight penetration, glare control, thermal comfort, natural ventilation, and similar factors. They also define building energy modelings, so-called BEM, to check the energy performance of the buildings. I think there are many human resources who can perform the building energy modeling, but there are not so many who can do the DPM, design performance modelings, because it requires high skill to understand the simulation outputs correctly. So this is today's last topic from me. I would like to briefly introduce my graduate student work. This work is undergoing by one of my graduate students. She joined the student competition when she was undergraduate and developed her skills. She works for proposing new future of building designs. She is struggling to develop new structural design possibility from the viewpoint of environment aspects. She is trying to combine daylighting design and topology optimization, so-called generative design. She is using software Fusion 360 for the generative design to create porous columns and beams. It could propose a design to reduce construction materials and embodied CO2. Space openness is also improved. To be honest with you, I have never used this software and no idea how to use it, but she could learn how to use them by herself based on her developed skill when she was undergraduate. Then she also used the daylighting simulations to find the best solutions with the structures. The porous building frame allowed to bring daylight deeper into the room. It can improve some indices related to daylight designs. UDI, useful daylight luminance improved, and the mean luminance improved from 32 to the 80 candidates. As I mentioned before, I believe that an innovative design and technology are emerged from a discovery of new problem and challenge. I believe her work is about to achieve the goal to be an innovative works. So this is a summary from today's presentation. So that's all. Thank you very much for your attention.
Thank you, Professor, for your incredible insights on environmental simulations in architecture education. Professor Hiyama Kyosuke will be back with us again for the Q&A session at the end. Thank you, Professor.
Thank you.
And now I would like to introduce you to our next speaker, Dr. Acharawan, who is a chairperson of the Building Technology and Innovation track at the School of Architecture and Design, KMUTT University of Technology, Thonburi. She completed her Bachelor of Architecture at Chulalongkorn University and Master's in Architectural Engineering in Lighting from Penn State University before earning a PhD in Building Technology at Massachusetts Institute of Technology. And today, Dr. Acharawan will be provide us with insight about digital experience design in research and architecture. Please welcome Dr. Acharawan.
Thank you very much, Atom. Thank you for having me today, and I would like to share my work on digital experience design in research and architecture. So today's content, I would like to talk about three important issues, which is my own research together with Chulalongkorn University on the road lighting performance, on color of light and intensity of light. But when we raise the questions, so there are some pain points around about the measuring method and tools available. And therefore, along the way in research, we invent affordable light measurement tool and also road lighting design tool along the way. And we did this research for the Department of Highway. And the last is a tool for design and digital in building operation, design and operation, which I could share the real work on that. So let's come to the first one. Um, as many of us know that the lighting measurement is many times we measure in luminance, which it's required quite an expensive tool, which is camera or CCD camera. And in practice, roadway lighting, when they measure lighting, they have to close the road and measure point by point, or close the road and take a photo. It's quite expensive and it takes long time and it's not affordable. And that comes to our innovative research in creating the tools for them. And so the objective of this research is to create the measuring method using uh, cell phone, and therefore we need to select a good method and do some calibration, and as well as to look at the human behavior in how they use it. And so at the end we install the real lighting poles and measure and do the real driving performance. At the end we have recommendation on light level and color temperature for the road. So like I said, normally we have luminance meters, and it's quite expensive, and we need to create something that is affordable for all. And so we thought about cell phone that is uh, available. And so we try to select some of the uh, uh, six cell phones in order to measure its performance compared to the the real expensive camera. And so yes, we try to test it, and we see some of the what we call error factors. And so we found some similarity on those machines, and so we embed into our software tool. Yes, and then we use quite for measuring the image into displaying into the color coded. Actually, the calculation method is there already long ago, and we just used to integrate into our application and cell phone. And so we calibrate against the expensive tool and have some kind of curve in order to correct the my work. And then next step is we not only to create the tool, we have to find out what kind of color of light and what kind of lighting intensity would be good for Thai eyes. Because many times many standard for lighting we copied from the West or international standard. And now it comes to color temperature and our cultural differences. And therefore we constructed the studies with Thai eyes on the railroad. And the study method, we let the people read the signage at different height, and they do the real road driving performance, and they read the signage, and we use voice recognition to capture if it's error or is it correct, and use the GPS to really capture the distance, how far from the driver to the signage that they can read. Yes, and we experiment on different variables on different lighting color temperature, 2000, 4000, and 5700 Kelvin. And we reduce the light level from 100% 25 to 50% according to the normal standard. Yes, and it's quite difficult because we have to do it in the railroad. And how are we going to control? We have to cross the road, and so we use the cloud and also the Bluetooth in order to control lighting intensity as well as the light color uh, on the railroad. And this is the picture how we use the real subjects to read the signage and to capture the road brightness. We found now there's no significant effect on the color temperature on the visual performance, but the brightness is. Yeah, however, compared to traditional lighting on high pressure sodium, LED is better all in all the color temperature. But in fact, many times when we make a decision to use the color temperature, we look at many things. For example, preference, not only the driving performance. We ask them to do the questionnaire on their like, what is their preference, what is the comfort and glare issues, and we measure uniformities and brightness. So there are so many dimensions in decision makings, and we found that around 4000 Kelvin for Thai eyes is quite suitable for the road. And when we dim down 75% is also quite acceptable. So let's move to the next step. And so that one was the one that we developed the method of research for and the measuring tool. And next question is the Department of Highway said that they need a kind of lighting design tool that is very simple, because these days the lighting simulation is quite complex. However, for road lightings, we could eliminate the reflected component from the surrounding, and so we use the basic one, and we use it embedded on the cell phone on the real site, where they can take a picture from the real and then online, and then they could use the tool on the cell phone on the real site based. They take a photo, or they could people can take a picture and upload it on cloud. So there are some people participatory that they can report the lighting performance on whatever road in Thailand, and that's synchronized with the database of the Department of Highway. And so, but there is also manual input as well, like traditional. So this one, we believe it or not, we work with our game making game maker. He's a German, and his high school students, believe it or not. So we work together on new experience on like the we could simulate the road, and we could simulate the like they drive in the real road, how they would look, how they would perform using game experience and engine. Is quite interesting. And not only that, we measure the lighting performance according to standard, what is luminance, uniformities, as well as energy consumption, and we give the star for each of the lighting design configurations. And they can even select the optimization method, even everything on cell phone. Very simple. Again, the equation is there already 50 years ago. We just use it, and then we use the engine, and we design the user interface. And so this is an example that they could select what type of lighting poles, what type of lamp, what type of color, or they could select what they want, and it could optimize the configurations for them. And so we calibrate by doing the real tools and calculation compared to dialogues. And so we have a good have to have the calibration factor in order to be quite accurate. So that is another example. Let's move to the last example. The tool for design and digital building operations. I give an example on the real building, Han building, and its green building received DGNB Gold Award, and it has been featured on the an architecture guide to the UN 17 SDGs Thai version. So this one is proudly present because it's one of the smart building where the process we involve in their staff and the owners, how to understand the use of the building, which is not a typical building because they have a lot of salesperson that come in the morning and afternoon nobody there. So we need to have a good operation system so that we don't turn on air condition all the time when there's nobody. And also lighting when it's open space, how we can group the lighting and how we can have everyone's participation on the digital. And we also create voting systems, like because some of them want higher light level, some lower, so the system will take the majority lighting level for the group of the people. So actually, yes, during the design process, we have done simulations on lighting energies as well as optimization during the development process on the life cycle cost for building envelope and glass. And okay, yes, we take into consideration of the SDG as well for and as well being in addition to energy efficiency into the building. Yes, for daylight and energy performance, we actually I integrate this one into my daylighting class, where students tried IES software to see the building performance, as well as Code.tool software. That at that time it was free for education. Yes, and then during the design process at the development, we use the very important variables in energy consumption, which is wall performance and glass performance. Now this time we collaborate with the ETS company that they use transit simulation on the life cycle cost for the initial and operation cost over 20 years. And so we got the recommendation for the design decisions. Now comes to the digital building operations. So I never thought that I have to design the application for their building operation. But now we have to, because the usage of the building is not the same. And so we use the tracking system as well as the Bluetooth beacon to track where the people are, who they are, and we use PoE light as the internet, and that could uh, get the signal from the cell phone, and we know who they are. And now we are looking at the patterns, how they use it, and hopefully we learn something from the patterns of the people, the lighting, and HVAC. Yes. Next is the building monitoring system, where we link it to the people on the exhibition space downstairs, and so they can see how who are there, and then how lighting is on, the temperature, the air quality and temperature. I think this is normal practice now, and we compare to the previous building, and it saved a lot of energy, and it boosts their happiness as well as their productivity, as we have done questionnaires. And finally, after they done the studies measuring the PV, and they done all the M&V verification, the system, and it comes down to 50 kilowatts per square meter per year. If we look at the Thai office building benchmark, the reference is about 219 kilowatt hour per square meter per year. And so it means that the building is quite well performed from the design process and also from the operation process. And finally, my summary is what we have learned is understanding user is a key, and utilization of available technology to achieve the goals is encouraged, and to create the tools is encouraged. We need to work multidisciplinary with other people, but creativity and vision must come first. And that's all my presentation. Thank you very much. Over to you, Atom.
Yeah, thank you, Doctor. And the projects you have presented to us was very interesting. And we will see you again in the Q&A session at the end. Thank you so much.
Thank you so much.
Yeah, and now I would like to introduce you to the third speaker of this event, Assistant Professor Waraluk Pansuwan. She is an Associate Dean for Academic Affairs for Architecture Design Program at KMUTT. About her background, she completed her master's degrees in architecture from Columbia University, the US, and her Master of Science in Interior Design from Pratt Institute, the USA. And today she will be providing us with the insight about Digital Rhapsody. Let's welcome Assistant Professor Waraluk Pansuwan.
Greetings. Thank you, Atom. I also would like to thank Dr. Acharawan who initiated this webinar and also the team who helped organizing this event. Okay, it's my honor to share my thought on how digital architectural education can leverage new technology for our future through the work that I have done both as a student at Columbia University and also together with the student work from KMUTT. Okay, I will cover 3 points that I think digital technology can benefit the future of architecture. 2 examples, one of mine and one of my students will be given on to elaborate on each point. The first point, I think as the previous speaker already mentioned, digital technology and software should be used as tool for design and experimentation rather than devices for visualization and imaging. Computers should not serve as a substitute for conventional drafting tools. The first project I would like to show is Urban Linkage. It's my first semester project at Columbia. In the first class, we were asked to pick 3 animals to study and make them into a chimera without telling how this exercise will develop into an architectural project. Also, speaking of the project title, Urban Linkage, we have no idea which typology of our building will be or for which program we were designing. After a long period of scrutinizing, I ended up at Tower Record buying a National Geographic video about camouflaging behavior in animals and picked 3 animals based on their ability to camouflage. Although I have no clue how this will lead me to a project, I did some study to understand how those animals can blend themselves with the context. There are several features in the animals that enable them to camouflage. For example, color, texture, and profile. The 3 operative techniques, pinching, diffusion, and multiplication are found. The chimera is a combination of sectional profile of all 3 animals. Now is the site. The site given to us was the plinth of Chase Manhattan Bank in Wall Street. The plinth of the bank was connected to the underground subway station. My intention was to apply the technique learned from the animals to diffuse the boundary between of the plinth and the subway station. So the underground station is more connected to the ground level. The boundary between them become unclear and difficult to identify where one starts and the others ends. The new subway station works like those animals by camouflaging itself with the context, which is the plane of the bank. This way of thinking gave me a very fresh idea how form and space could be instrumental to influence certain behavior or events. The justification of architecture is placed on the effects it's produced rather than on architecture as an object. This is an invaluable lesson I learned from my first semester. The next project is a student work, SoA 2050, from the third year studio at KMUTT. The studio posed a question of how learning pedagogies influence the organization and the design of learning space, and with the emergence of digital technology, big data, artificial intelligence, how the future architectural practice would be transformed and how the school of architecture should look like. Biomimicry is another key issue of this studio this studio would like to introduce in parallel with Grasshopper as a design tool. This student chose the slime mold to study. The interesting thing about the slime mold is that even though they are single-cell organisms, they are capable of working as a collective organism to form a tubular network that is optimized to transfer nutrients throughout the entire organism. There are many experiments comparing the networks created by slime mold and the city transportation network. The left diagram is a map of Toronto showing 17 transit nodes. The right image is a network connecting the same 17 transit nodes that was created by a computer simulation of slime mold. The students started to experiment with Physarum plugin to simulate the network of the slime mold. So these are some of the work. So to apply this concept of optimized network of slime mold to the design of architecture school, we need to identify the programs in the school that work similar to the food source. Food source programs are placed on different levels, and slime mold is placed in the center of the building. The script works itself out to form a three-dimensional network of circulation in the center of the school and connect all the supporting facility or so-called food source program. The volume created by the slime molds is placed in the center of the school to form a circulation and gathering spaces and connection to other supporting program or what we call the food source program. So these are some of the results of the design of the building. Okay, second point. With digital technology, architecture should be conceived as a dynamic organization. From Greg Lynn, I quote, "In architecture, the space of design is conventionally thought of as neutral space, but in other design fields, design space is conceived as an environment of force and motion. A good example is the form of a boat hull. It is designed to anticipate motion." My second project is CNN expansion for CNN headquarters in Atlanta and also CNN Online Pleasant. It's a two project in one semester, architecture and the website. We were asked to design both the new headquarters for CNN in Atlanta and the website. Today I will only focus on the design of the new headquarters. The current CNN headquarters is a high-rise building with an atrium in the center and a podium where commercial programs are located. The building is open to public. Visitors can buy a tour to visit their newsroom and production facility. After visiting the building, I try to reconceptualize the boundary between public and private space in CNN headquarters according to what has happened using digital model in Maya. Instead of assigning the public program to the space at the podium and the CNN newsroom and studio to the interior of the donut, I use blend shape tool in Maya to manipulate the topological model of the donut to allow it to register the flow of the visitor on the surface, as well as to redefine the boundary between public and private to the extent that they become unclear. So the distorted donut is put in a box, then subtracted out to form a continuous void in the space, exaggerating the mixing of spaces between public and private. The original conceptual model then stretched and refined to fit the program and used as newsroom. Since the new design of CNN headquarters incorporates its newsroom, so the continuous newsroom also becomes the new image of its online presence. So so this one is kind of merging between the two projects. So the new headquarters, the image of the new headquarters become also the image of its online presence. Okay, the next project, urban furniture competition. The student work sequence is selected as one of the 10 finalists, and the one-to-one prototype is currently being developed by the student. The design SittoTransfer is a seating that anticipates movement on the assumption that the posture of sitting also has to do with duration of sitting and psychological condition of the sitter. Beyond the standard human figure, a form of a seat can be shaped in association with those dynamic factors. Students started the project by mapping different posture, I think it's the previous slide, and dimension of sitting and try to relate different posture to time and psychological condition. The observation of commuter behavior at the bus stop also show that the position and duration of sitting are varied. Some people sit on the provided seats, some stand. The four typical profile of sitting: low sitting, normal sitting, high sitting, and leaning are locked together to form a dynamic surface for sitting that anticipate different posture and need of the commuter. So the four sectional profile can be combined. If you look at this slide, the four previous four sectional profile also can be recombined in different sequences, depending on the context of where the seed will be placed. So here are the example of how different configuration can be generated for different contexts. For example, office, shopping mall, or art and cultural venue. The third point, with software, okay. So with some software that is capable of handling parametric design, architecture could be thought of as an envelope of potential, a model for numerically controlled multi-type that is flexible, not a fixed prototype. Generative system for skyscraper. This project was my last project at Columbia. We were asked to work with BLEPs, which is condition of self-intersecting surface, which considered as mistake and unmutable by the milling machine. These mistakes should be explored systematically and opportunistically to create a single surface enclosure with inherent system of structure and enclosure. I started this project by studying the circulation of Frank Lloyd Wright's Guggenheim Museum on the Fifth Avenue and found that the ramp of the main exhibition is a continuous surface that allows a gradual transition from the street to the top floor of the exhibition space. The diagram of the Guggenheim Museum was taken literally and turned into a new skyscraper. The first model, which I call a primitive, looks like Guggenheim Museum without floor. To have floor, two pieces of cones have to be lofted, crisscrossing each other to form a manifold surface with semi-enclosure. So I consider this as an envelope of possibilities. Then I start to combine the original module into towers and see this prototype not as a fixed prototype but a flexible system that can be used to explore design options. Practical parameters like GFA, unit size, unit type, ceiling height, etc., can be incorporated to develop this envelope of possibility into a residential tower. The final piece is a three module tower. The size of the module can be varied. The model was done manually in using Maya software. In the last decade of the 90s, Grasshopper was not available in the market. Maya was the tool we use in school. If you would like to use scripting, mail script is available in Maya. The last project I'm going to show is a student work, Dindang Social Housing, a 19-story residential tower. The brief is very practical. Programs and sites are taken from the real project by the National Housing Authority. We also introduced Grasshopper to the student. We were looking for more options of how scripting could be practically used in the design process. So from the brief, every unit must have the same square meter, which is 33, since this is a relocation project. The construction cost was partly subsidized by NHA. This student started with the idea of unit with sharing balcony. Instead of a small room with small balcony, individual balconies can be combined into a larger one that can be shared among the 2 or 3 units. The combined unit has 6 types. Also, to reach 50% efficiency, a double-loaded corridor configuration is adopted for the floor plan of the residential tower. Each floor can accommodate around 25 and 26 or 26 units, and only 3 duplex units can be placed on one row. Grasshopper script is used to help identify the location where those duplex units could gain the best view of the city. As a result, duplex units with larger balconies and good city view can be utilized for social gathering within the community. Okay, to conclude my talk today, I think digital technology is only the starting point that open up for more creativity and imagination. And I would like to end my lecture with a quote from Greg Lynn. He said, instead of approaching computer as a brain, it might be considered as a pet. Just as a pet introduces an element of wilderness to our domestic habits that must be controlled and disciplined. Computer bring both a degree of discipline and anticipated behavior to the design process. By negotiating the degree of discipline and wilderness, one cultivates an intuition into the behavior of computer-aided design system. Also, before finishing my talk, I would like to thank my studio critic at the Graduate School of Architecture, Planning and Preservation at Columbia University, my student at KMUTT, and also my colleague from at KMUTT. Thank you very much, ka. Back to you, ka, Tom.
Thank you ค่ะอาจารย์พึ่ง we will wish to have more discussion about this topic so we will see you again in the Q&A session at the end ค่ะ thank you so much ค่ะ Next is the last speaker of the day, so I would like to introduce you Ms. Sukhumarn Thamwiset or Janbo. She is currently working as an architecture lecturer at KMUTT. She completed her master's degree in architecture and urbanism from Architecture Association School of Architecture from the UK and her Bachelor of Architecture International Program, KMUTT University of Technology, Thonburi. Today she will talk us through parametric size patterns and decoding traditional Thai patterns. Please welcome Ajahn Bo on stage. Hello.
Unmute. Sorry. So thank you for the introduction. So I will be sharing my research from quite a while ago about decoding traditional Thai patterns. This research topic is a personal interest of mine. It's an easy introduction steps into computational thinking and logic and seeing complexity in things around us. So the key element in this research is decoding the construction. Decoding is trying to extract essential information, how things are constructed, either abstractly or physically with precisions. The key would be with precisions. Anything can be decoded, and it's interesting because computer is objective with no emotional preference. So with precision, it's something that architects like us would understand and like. Patterning is different than just repeating of something because by nature it requires structure in order for something to be repeatable and sequential. And there are this sort of agency behavior in small scale detailing that results in larger fields reactions. So traditional Thai patterns, it developed and exists along with our nation and culture. Thai pattern is a combination of multiple cultural influences which we adapt and we use in everything from daily life objects like homewares and ornaments and clothing to architectural scale. And because it has a clear historical development, we as a Thai are familiar with and can identify it. Patterns in Southeast Asia as a region would all look very similar because all derive from similar source, such as natural inspired objects, beliefs from Buddhism and Hinduism methodologies. In comparison to Islamic patterns or other Asian patterns, like Chinese or Japanese, the unique points of Thai pattern would be that it's based on curves, while Islamic or Chinese would mostly, if not all, made of straight lines. And being made of straight lines made them more mathematical in their construction, and you'll be able to patterning them with more precisions, while the Thai patterns would appear more organic and free form. So it's a bit of a challenge that we set up to try to have some logics with their drawing methods. So this reflects how traditional Thai patterns were taught previously. It was never properly recorded or properly taught. These books are were made only relatively recent, considering how far we've been using the patterns over hundreds and hundreds of years. So there were basically no text, just recording of pictures of drawings, as you can see here. These are example of one of the prominent books on Thai patterns. And in the old days, if you want to become a craftsman, you go work under a master and you learn through seeing and copying enough amount of time while training. And through this practice, physically speaking, you build muscle memories in drawing the curves, and aesthetically speaking, you develop an eye for what is considered beautiful. So it's a similar process to machine learning. You've done it many times enough to know the minimum and maximum of acceptable range. And there are two levels here that we are researching. From the first is the actual drawing. It's called Lai Thai, or base. These are baseline drawings, and then there's a patterning of these little drawing, which is called in Thai Puk Lai, which means tying them together. So there are many drawings and patterns. So for the sake of the limited time today, I'm going to use this one pattern to explain the process of this research. So while Thai patterns look organic than most other patterns, it's actually not organic, structurally speaking. They're based on something with adds on to make it elaborate based on the usage. So what we're doing is using the same method as how any craftsman was previously taught, by drawing lots and lots of drawing in an excess of thousands for each patterns, using code and overlay back to the master drawings on recording in the book with acceptable tolerance of about 5% to preserve the authenticity of the patternings. The first factor relevant is curve and understanding how computer draw a curve and the element that controls the curve. So it's about control points, and it's about degree, which we feed in a form of numbers. And we want to gather majority of the information in the form of numbers because the number give range of varieties that we can recreate. And it's a language that computer can understand. So we started our decoding journey by gathering master drawings, which we already tried to understand, which they already tried to understand with grids and sort of points that they remark unspokenly, and we repeat that process. But we added computer language like access and precision in terms of scale. And through a series of many drawings with scripting, which we test the variance of acceptable ranges from testing the base construction proportions. And then we draw the curve through to using varieties of control points and curvatures. And we went through the process of identifying where exactly are the control points. And as I mentioned, the 5% acceptable tolerance. So we test by moving these coordinates. So once we identify the control points, we look at the 5 range in X and Y axis of all of the points, and then we go through the process of moving the points. It's like mathematical probability type. So you eventually ends up with lots and lots of drawings, and then again test back, tracing back, overlaying back to the master drawings, and then we identify the range of acceptability in numbers, which we feed back to the scripts. So when we redraw the correct script, we would be setting up the acceptable range. And the most difficult part in the drawing was actually the embellishment. The tie patterns are highly decorative, and we identified that it was done through either by layering or this carving actions. So we went through a similar drawing process of how computer might draw these carvings and then test the proportions and the coordinates of carving lines, the curved lines. So we understand how we might draw, and then we script, and then we test the coordinates and we script again. And then we test the variance of these points. And then we place the control carving onto the drawings and see the range of how deep the carving can be and how many carvings you can add onto particular drawings. And then once we get to the patterning action,ผูกลาย, it's tying the drawings together. It's the process that uses these line drawings to join to form something. So patterns will all have names, and actually the drawings have names, the patterns have name. This one particular one I'm showing, it's called บัวคว่ำ lotus facing down or lotus facing up. The drawing imitates lotus, and because it's using as a trim, usually a trim of a statue or trim of a stupa, we analyze how the structure of how these patterns are tying together by coding, and again we test the range of it to identify the acceptable range. So the บัวคว่ำ pattern is about overlapping, so we test percentage of overlapping by moving on the x-axis. And we went through several versions of movements on the second layers and then third layers, because usually there are 3 layers in these drawings. And then we matched the second layer and third layer together. So the probability, the numbers of drawings that we can generate were quite massive. And then as a result, we will come up with this sort of formula with the range number, like minimum, maximum range. And then you can generate the patterns, the actual line drawing, then the patterns within the range of authenticity. And we repeat similar process to many patterns that are used regularly in any traditional Thai objects, like these ones you would be familiar with. And with these process, what it gives us is formulas for the base drawing and for the patterning, which we can give range of acceptable variations in numeric form with decimal points coordinates for construction. So meaning that we can generate millions of possibilities of drawings, and 2 drawings doesn't need to be exactly the same. They can have variations of embellishment, and they might have if they're being hand-drawn. These are stars. The pattern is called star. It's used on the ceilings in temples, so you can have millions of varieties that can join together. So then we set up the code so that you can give the parameter in form of surface areas, then generate the patterns onto it. Again, you have the full control of the level of patterns, and then the level of embellishment you can make decisions based on the usage, and it results in 2D drawings currently, but this can then go through fabrication process because the files are computer made. We have several versions of things that you can generate. So the interesting part is these have larger meanings, and because when they are used in larger scale, we mustn't forget that they are a part of something. Um, because while this knowledge, we can start looking at larger picture from the bottom-up organization point of view. Because while we take them as just decorations, they have an agency-like character, as in they're the base of something that shapes something larger, simply speaking, the like bricks. So we understand scale and proportion of these line drawings and patternings, and it's will go on to shape the form of the Thai architecture like stupas and jedi. So potentially we can use this relationship to decode like the proportion of Thai architecture and what we perceive as authentic and beautiful. And yeah, so that's it for my presentation. Thank you.
Thank you, Janbo. So we hope to see you again following the break in the Q&A session so we can have a little bit of the discussions. Thank you so much. Yeah, and we are now proceeding to the last discussion panel, the Q&A session. If you have any questions or are interested about the work, please feel free to comment them in the chat box for the discussion. Thank you, and we'll be back in a few seconds. Welcome everyone back to the last Q&A session. We are back with our speakers, Professor Hiyama Kyosuke, Dr. Acharawan Chutarat, Assistant Professor Waraluk Pansuwan, and Ms. Sukhumarn Thamwiset. And now I have prepared some questions for us to discuss about. So I'm going to start my first question now. So what do you think are the most important architectural skills that will be beneficial for the preparations of the changes in technology for our future? Anyone can answer my question.
I would like to answer. Yes.
Yeah.
You hear me at Atom?
Yes, I can hear you well.
Yes. I think I like everybody's presentation. Actually, it has in different angles, and all are important for architectural design. And in addition to all of the speakers, I would like to add about artificial intelligence, that how we can utilize or leverage, into not to replace us, but is perhaps the design suggestions or some ideas for brainstorming, or as a starting point. And so there is many possibilities, and I think that won't limit our creativities. I think that one is, it will be benefit, also how to use technology into the design. That, but maybe I don't answer, but I add my thought into what is missing from all the speakers. Ka. Anyone want to add?
Maybe I could add. I am not sure because you talk about architectural skill, but I think the skill that we all have are more or less like, I think using a common skill as like other people, like critical thinking, creative thinking, and I would say for me, I think technology is a starting point, but that we should think, it's not the technology itself is the most important, but I think humanity, creativity and imagination is still kind of very important for architecture.
Can I add some to your comments? And yeah, I think so. Yeah, I'm agree with both of those comments. I think in the architecture design, we have no single answers. So that's why yeah, we have many variety for the answers. So how to create the answers? The important thing is how to find the program or find how to find a new challenge and how to find the what you are interested in. So if you could find some, maybe you can reach some new things. So I think it's a very most important things for the to be the architects and for the architectural skills. I think yeah, that's my opinion. Thank you.
Thank you for all of your answers. Ajahn Wu, would you like to add anything?
Um, I think digital skill is the kind of the end of the spectrum. The first thing you need to do is you need to develop, you control the machine essentially. So you have to be able to think logically first. That's the most important thing because as a trend, we usually see students use digital skills as kind of a recipe for flashy forms, and that's actually that's not how it should go. Um, and I would think that you can and these computational thinking you can start manually, because it's logic. It's just a computer can calculate millions time more at once. So I would probably say to me the most important thing that you need to develop before you start jumping into computation would be a logical person.
Oh, okay. So thank you for that answer. My next question is also related to all of your answers. Is that with the use of technologies or digital programs, will it limit the creativity of the design, or is there any limitations from using technology at the moment?
Yeah, very interesting.
Like for
Whether it
me,
will
I
limit.
like yeah. I think for me from when I do it in class, sometime when I use technology in my work, I sometimes lost the basic understanding because like the technology. So I don't
Mm.
know if there's any limitation. What do you think?
I
Okay.
it's a different for me. It's a different thing because you get lost because you're not in control of the
Mm,
skills. Software skill is one thing, thinking is another thing. If you're on top of the software skill, it won't limits you. But if you're not, you're if you're not your skill is not proficient enough, sometimes you kind of get lost in the generating things in computer, and then you forgot why you're doing it. So you let it drives you.
mm,
So
mm,
it's about who have the who's in the driver's seats, and you you
mm,
you you have to always try to be the one who drives the technology rather than it drives your projects.
mm,
That's
mm.
my answer.
Okay. I would like to add to Ajahn Bo. Actually, it's very interesting discussion always, this topic. And may I kind of refer to the end of my, talk, that I quote for Greg Lynn, that he talked about that, you really, I think, it's two things. To be able to control the computer is also, okay, I think it's good that you can manipulate it, as what Ajahn Bo said, right? But another interesting thing is when he said that, uh, you know, he would like you to see the computer as consider it as a pet, right? Because the pets also kind of bring the elements of wilderness. Mean, sometimes if you cannot control it, it's kind of give you some open up something for you. So I think it's kind of balance between the two. I think you should also open for, like for example, my last project, the generative system for the skyscraper. We kind of trying to explore the mistake of digital model, which is a self-intersecting surface, which normally if you would like to use those model for digital fabrication, the machine would not recognize that surface, right? So you have to do something with them. But also the bleb itself is open up for some opportunity for the manifold surface to have enclosure. It might be a bit too difficult to understand, but overall, I think it's also, without ability to fully control the software, also like you can play with it and maybe you like try to work with them creatively, something like that. Ajahn Acharawan,
You,
maybe
your mic.
your mic is mute.
Oh, I see. Okay. I would like to add all of you, and especially Professor Hiyama, in your lecture. I like the point that you say that we need to discuss the results of the simulations, right? What's going on. Many times students didn't provide enough time for discussion. Maybe they run out of time and then just present what there is and without knowing what's going on. And I think this is important in architectural education where we we let them manage, like they know what they are doing and know what the outcome and what it means. Yes, and we should help it to use the computer to help in our design, not to limit our design. That's all.
May I add something? Talking in terms of like a user, the technology user, I never think that like to use the software or like the technology limit the creativity or like the our thinking and all. I never thought that you have to separate it, because as all the professor here or the teacher here talk that we use the technologies as a tool. It cannot control our thinking at all, in my opinion. Yeah.
Yeah, I'd like to some add. So the most important thing is who makes the decisions. So if we rely on the computer so much and ask them to give answer, I think it's very dangerous. So it means if we ask them to give us choice, so which is preferable or something like that, and finally the human and the architect should make the decisions which we will choose to our make our directions. So that is the most important thing. So how to afraid how to do not limit to our creativities. I think. Thank you.
Thank you for your questions. I'm gonna move on to the question from the ground, which is architecture is built on collaboration, and we don't see ourselves as dominating our human collaborators. Do we always view technology as something to be dominated, or can it advance to be collaborator?
Okay, may I try?
Yeah, sure.
Yeah, I think it's very similar to the previous question. I think when you work with any, I would, again back to Ajahn Thanyalak, kind of remark previous, um, I think, when you work with any kind of tool, it's a kind of collaboration. You have to accept, if you use watercolor, you use acrylic color, oil painting, those kind of things, it's always influence your, how you're going to work with them, the result of the work. I think it's very similar to computer. I think it's a kind of tension between the two. We are trying to control them, we're trying to dominate them, but also, you really, it's like you really cannot like completely, but also you have to work with them, you have to understand them in order to work with them. This is a collaboration that I would think ค่ะ
Like in my example, we use technology to help human to work better, to collaborate better. So it's I agree with Ajahn Pung that it's quite similar to previous question. So it's a matter how we manipulate or how we utilize the computer. ค่ะ
yeah, maybe I don't think it's about like kind of fighting between digital technology and human. Yeah, I think maybe I don't want to see that as a kind of vs like versus like human and technology, right? I think we can kind of work together, and it's always like if you um remember the printmaking, when we start to have printmaking, right? Gutenberg, right, invented, and Victor Hugo, right? This will kill that, the printing will kill architecture, but it's not like that. Architecture is still, here, and the print is still, it's kind of work together. And I don't think digital technology will dominate architecture, or architecture we just live together.
Okay, so anyone else to add on to this question? If no, then I'm gonna ask my next question, which is the last question that I have for everyone. So from listening to all of your slide, I have a question about like, do you think these new technologies can be integrated with conventional construction, or as they're like, I think there's a different in design process comparing to the past. So like, can it still keep the characteristics of the style, like the Thai vernacular style? That's my question.
I think you probably asked this because you've never seen anyone doing a square building using like grasshopper. Um, it's not it's not a form generating question. I think it's just that like every other question, and as Anpung already answered, it's how you apply the technology. So it already is being used with traditional construction, and it will continue to develop on both analog and digital together, us and because construction technology changes too. So it like as Anpung say, it's not this versus that. It's just that different track, and you don't necessarily need to use computer to be digitalized. That's another thing I want to add. And it's not about form making. So if we take out the preconceptions of what digital computational architecture should look like, and you just focus on the actual meat of it, the logic behind everything, you will see that any type is computational. Like I always feel like Mies van der Rohe's National Gallery is very, very parametric, because he knows the scale of everything. Nothing's being cut. All the materials are precise. The precision is the key. So I don't think we're taking one thing away from another. It's just kind of how you apply them.
I think I would like to hear from Japan. Maybe Professor Hiyama have some experience to share with us. Anything from Japan?
It's very difficult to answer. So yeah, of course, these new technology can be integrated with a conventional construction process, and we are
Mm,
going on. And but still now human being managing the project, and the human being cannot change our process so rapidly. So the speed, the speed for the development for the technology and the speed that we can change our process is a large gaps. So maybe we need some more time to change our workflow or something like that. But actually, yeah, we are changing. So
mm.
in 10 years or in 20 years, maybe the process will be completely different from these days, I think. Yeah.
Yeah, I would like to add one thing. Yeah, I remember, a documentary by a professor in Spain. Like he's working on the Sagrada Familia. The building initiated by Gaudi and couldn't finish. Right now, we are using parametric and digital software to really, kind of learn like the origin of the idea of the structure, and also like using those digital technology for, you know, um, the Sagrada family. The building has been there for, 100 years, right? Yeah. So I think this is a very good example.
Mm.
Yeah.
I think what it can help, for example, maybe the collaboration process. Long ago when I was young, the architect design and send to engineers, send to construction. If something change, we change all the drawings, and there could be something missing that we forgot to change or whatever. So I think in the future, BIM, building integrated modeling, could help in integrating in both design and construction to have less, mistakes and more precise for the bill of quantity as well as less waste. So I think it helps, in improving uh, into a better and better ways. Not only that, it have good simulations or even VR together. It help clients or students to understand better. Yeah.
Okay, thank you for your answers. So, do you have anything else to add on to like the overall discussion today? You may end now. I'm going to finish this session soon. Do you have any? No? Then,
Yeah.
I think we are. Yeah.
yeah. I would like to thank everyone for having me here. As a design student, I have understand a lot more about the use of technologies, and yeah, I hope that I can apply some of like the knowledge here that I learned in my school life now. Thank you so much. And yeah, this is it for our last episode of first webinar series 2022 by School of Architecture Program. So thank you, Professor Hiyama Kyosuke, Dr. Acharawan Chutarat, Assistant Professor Waraluk Pansuwan, and Ms. Sukhumarn Thamwiset for this very educational session. Thank you so much.
Thank you very much.
Thank you,
Thank
Ka.
you.
Very
Thank you.
important.
Thank you, everyone.
Thank you, Ka.
So, as the event has come to an end, I fear everyone has gained a lot from our speakers' presentations. Again, I would like to thank everyone for attending and participating in our final webinar series episode. And please don't forget to follow us on social media for the next series. I hope to see everyone again for the next lecture. Have a great afternoon. Thank you, everyone.